Welcome to GrayYeon math. We are given our three squares with side of two units. Find the area of the right triangle which intersects with the vertices of the square. But before that, may I request you to please like this video and subscribe to the channel. You can pause for a moment and think of a solution that you may have for this problem. Okay, so first step is we consider these squares, and these squares form a right triangle against the base of this red triangle. And since these are squares, then this should be 2. And this should be 2. And this is a right angle. And this becomes a right triangle. But if we call this distance, this base of the red triangle, we call this as B, then that is the hypotenuse of this right triangle formed by the red line, which is the base of the red triangle, and also the hypotenuse of these triangles with dimensions of 6 as one leg and 2 as the other leg. So we have B equal to the square root of 6 square plus 2 square, and B is equal to square root of 36 plus 4, and B is equal to the square root of 40, or B is equal to 2 square times 10. So B becomes 2 square root of 10. Okay, so next thing is we focus on the angles on this figure. So we know that this square on the rightmost part against this red line, we have this as 45 degrees. And if we say that this is alpha, then this angle is 45 minus alpha. And this angle should be congruent with 45 degrees since they are alternate exterior angles. So we have this to be 45 degrees also. And if we draw a line from the topmost part of this triangle, then we form a smaller triangle. Then this should be also 45 degrees, a complementary angle with this 45 degree here. So if that is 45, then if this is 45 minus alpha, and this is alpha, then this should be also alpha because they are alternate interior angles. And this should be also 90. And this angle should be also alpha. Is alpha. And if that is alpha, then because since this is this one is alpha, and this whole angle should be 45 degrees plus alpha. Okay, so next thing that we need to do is we need to find the value of tangent of alpha equal to opposite. If we focus on this triangle, the first triangle, which is composed of these three squares and this red line, the opposite side is equal to 2. The adjacent side is 6. That becomes 1/3 equal to 1/3. Okay, so next thing that we need to do is we need to use the formula for the difference angles for tangent. Then, because we have this tangent of 45 minus alpha to find out, so that would be tangent 45 minus tangent alpha divided by 1 plus tangent 45 times tangent alpha. And tangent 45 is actually equal to 1. And tangent alpha, earlier it is 1/3. And 1 plus tangent 45, which is equal to 1 times 1/3. On the numerator, this becomes 2/3. And on the denominator, this becomes 4/3. So we cancel this 3. And this, we have 1/2 tangent 45 minus alpha equal to 1/2. Okay. So next thing that we need to do is we need to find this distance. Let us call this as h. So since we know the value of tangent 45 minus alpha, then we are now ready to find this h. So that will become the opposite over the adjacent side. So but tangent 45 minus alpha is equal to 1/2. And the opposite side, which is h, is actually equal to what we are looking for. And the adjacent side is actually equal to b, or the base of this right triangle. Then we have 2 squared of 10. So h is equal to 1/2 times 2 squared of 10. So we have h is equal to square root of 10 units. Now for the final step is we are now going to find the area. Area of any triangle is equal to 1/2 times base times height. So area is equal to the 1/2 times the base, which is 2 square root of 10, and the height, which is square root of 10. So we simply cancel these 2 and 2. And the square root of 10 square is actually equal to 10 square units. And that is our answer. Please write in the comment section below if you have your solution for this problem. Thank you for watching until the end of the video. Please like the video if you like our solution. And don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.